There are various methods that we can use to determine limits of functions, and we can start with some fairly simple principles to do this. So one of the things we can do is, for limits at infinity, we can look at the powers of functions, okay, or the relative strength of functions. So in this case here, since the highest powers are equivalent, we can say that the ratio of the highest powers, the coefficients on the highest powers, will give us the limit. So in this case here, we can say that these are insignificant when x gets really big. So we end up with this ratio of 2x squared over negative 3x squared. These can essentially cancel out, so we end up with a limit of negative 2 over 3. So the limit is negative 2/3. So if we were to graph this, we would see that there is the horizontal asymptote, because this is endpoint behavior. The horizontal asymptote would be at negative 2/3. There are other ways that this can be done, and we don't have to do it this way because we can still do this informally, but a more formal way might be like this. So limit as x goes to infinity, we're going to divide all the terms by the highest power. So we end up dividing by x squared, we're left with 2. We end up with square root x over x squared minus 3. And since this denominator is bigger than this numerator, this tends to 0. So we end up with 0 plus 2 over, and again, this denominator is bigger than the numerator. So we're going to end up with 0 here and then minus 3, and we can show a little bit more formally that the limit is negative 2 over 3. But we don't need to do this formal method. We can use an informal method. For b, this is a little bit harder because as I plug in 0, okay, so as I plug 0 into here, I get log 1, which is 0. And the square root of 0, the sixth root of 0 is 0. So I get 0 over 0. Now this is a problem because it's indeterminate, but because it's indeterminate, I can apply L'Hopital's rule. So to apply L'Hopital's rule, I need first the condition. So I have the condition of 0 over 0. So if I have that condition, I apply L'Hopital's. And applying L'Hopital's, I differentiate the numerator and I differentiate the denominator. So this becomes x to the power negative 5/6. Okay, and sorry, 1 over 6, x to the negative 5/6. So I'm just going to put the parts, rearrange this so I get x to the 5/6, and that's 6 over x plus 1. Okay, in the denominator, oops, I need to make sure I use my limit notation. So I have the limit as x goes to 0 from the positive side. This is going to end up being 1 over limit as x goes to 0 from the positive side, 6x to the 5/6 over x plus 1. When I plug in 0, I'm going to end up with 0 over 1. And so that's equal to 0. So the limit of this is equal to 0. So if I were to graph this, again, we would end up seeing that this tends towards 0. This one here, we can do some algebraic manipulation. When we plug it in, we're going to end up with 0 divided by 0. We could use L'Hopital's, but in this case here, we don't really need to use L'Hopital's because this is a quadratic which we can easily factor, and we can algebraically manipulate this. So we end up with x plus 5, x minus 2 divided by x minus 2. So when we simplify this, I can now evaluate this limit because we no longer have this 0 divided by 0. So when we evaluate this limit, the limit is equal to 7. So this rational function, this becomes a linear function, but it ends up with a linear function with a hole at x is 2, y is 7. When we look at the graphs, limits from graphs are fairly straightforward. We just see what's happening as we find the follow the graph to the limit. So in this case, x goes to positive to 1 from the positive side. So it's going in this direction here. So I'm just going to color code this. So this means I'm going in this direction. And again, the limit is not where we end up. So we end up at 1, we end up at 2, and y is 2. But the limit is, as we're approaching 1 from the right-hand side, we're approaching the limit of 4. So the limit in this case is 4. As we approach -2 from both sides, this is a two-sided limit. We're approaching -2 from both sides here. Okay, being a two-sided limit, it needs to be going to the same point from left and right side, which it is, and it looks like it's going to 3. And again, the value at f of -2 is not 3, it's actually 5, but the limit is not about where it ends up, it's about where it looks like it's headed. So in this case, f of -2 is 5, but my limit is 3. As x approaches 4, okay, from both sides, as x approaches 4, it's going to look like this. I'm approaching 4 from this side and this side. Well, I'm going into two different directions, so the limit does not exist. Okay, one's going to positive infinity, the other one's going to negative infinity. The limit does not exist.